So this is Math Analysis Honors. So this is our Math Analysis Honors class. And this is what we call S4. So its official name is inverse normal distributions. So we did S3. We did S3, and you did homework on it. That was what was due today. And that was going forward. So this is going backwards. So in S3, we saw how to find the percentage of data values from a set of normally distributed values. The normal distribution is the only continuous probability distribution that we will be looking at this year. But there are many in your future math classes past calculus. Okay, so the same as, I can kind of give you an analogy here, is think of, you know how you find that the sine of 30 degrees is 1/2? And that means you could write sine inverse of a half equals 30 degrees. We're going to use a notation that's similar to that, but with our normal distributions instead. So this is just the inverse notation that you're used to. So what we're going to try to do is we're going to try to go in reverse. Okay? So in reverse, what you're given is you're given the probability. Or you're given the portion, or usually I think of it as you're given the area. Okay, so when you have a normal curve, looks like a pretty sucky one. Okay, so when you have a normal curve, what we were doing the other day is we were taking an x value here, and we were taking a z value here. And with the x that we knew, we could calculate the area, or the portion, or the probability, or the percent, if you change it to percent sign. But now we're going to be given this area. So we're going to be given this area as a percentage or as a decimal. And then our job is going to be to find x. So we want to find this right here. Usually they'll call that a. Now our calculators kind of do sometimes it as a shortcut, but it'd be good for us to know how to do it the long way in case it gets a little more complicated as well. So the calculator will get you a, but it won't give you other things that sometimes you need. So basically this is the setup, and the question is, what is a? Or sometimes they're going to ask you, what is sigma, not sigma, mu, or sigma? They might ask you for those as well. So they're kind of interesting problems. So let me give you an example, and then I'll show you the official notation, and then I'll also show you how to do a shortcut on your calculator. So that's going to be important too, so that you can check your answers. But if you practice with the z-scores, then when things get more complicated, you have the structure to be able to go backwards in any situation and not just the ones that your new calculators do. Okay, so this is from S3. So from section S3, we said the mean, mu, of an SAT score, we were talking about math, is 500, and sigma is 100. Now what we were doing before, so this was in S3, so before we wanted to know the probability that x is less than 420 or less than or equal to, and we changed that to a probability or a proportion with a z-score. And then we use normal CDF. So this was before, this is a reminder. So this is, we use normal CDF on the calculator. And it gave us an answer, which was approximately 0.2119. So now, we're going to want to take the 0.2119 and go back and figure out how to get the 420. So that's our plan. So we need to figure out how to do this process in reverse. Okay, so a couple things. First of all, always draw a picture for normal distribution problems. It'll give you strategies to be able to use later, attack strategies. So I call this the X number line, call this the Z number line. So what if you were given this area? So if I was given that area, first of all, I do have to know whether it's to the right or to the left. In this specific problem, it was to the left because it's a less than sign. So if we were given the problem where this area right here is 0.2119, how would I go backwards and find out what A is? A is called the cutoff value. Okay. So now what we're going to do is we're going to use the method where we find ZA first and then we find A. So what we're going to do is to find ZA, you're going to use this notation. So this notation is a capital I with a circle. It stands for the normal distribution. I'm going to use the inverse notation, and I want to inverse this. Now, with the notation, this has to be the area to the left of A or ZA, depending on if you're talking about Z-scores or X values. So that has to be the area to the left. Now your calculator will do it if it's to the right or to the center, but then we don't have a notation for it. Okay, so this is going to give you the Z-score directly. Now once you have the Z-score, this is going to give you a decimal. And the only problem with the decimal that you get is that you have to round it. So I usually don't find the decimal first, and I usually do the whole process, and then later I use my calculator at the end. Okay, so basically I have the Z-score. So then I know how many standard deviations away, but then I'm kind of stuck. So hopefully when you were doing S3's homework, you were doing using this formula. So you had practice using this formula forward. So if you think about this formula, I now have Z, I am missing X, I have mu, I have sigma. So I have three things and I'm just missing one. So I will be able to go backwards. Now in the future, they don't have to have you missing X. They could have you missing sigma. They give you X. Oops. So they could give you X, they could give you Z, and they could ask you for sigma, or mu, in this case mu. They could ask you for mu, or they could ask you for sigma. Now the calculator won't do this one that I've just shown you, but it will do the one that we have in this problem. It will find X for you. So there is a calculator, and I will show you how, but there is a calculator way that it will find you X. It just doesn't find you mu or sigma if that's what you need. So I suggest practicing and just using the calculator as a double check. Okay, and you'll see this again in AP statistics. You would see this again in college statistics, and then you would see this again in HL math at our school. Okay, so the ZA is a number, is a decimal, but I just call it ZA, but I know we know it. X is A, if you look at the number line. Mu is 500, and sigma is 100. So then I need to solve for A. Now you guys are awesome at math, so you know how to solve for A. You don't really have to memorize this formula right here, this conversion formula. I sometimes call it the conversion formula. Okay, so how do you solve for this? You can cross multiply, so you get 100 ZA equals A minus 500. And then you have to solve for A, so that's 500 plus 100 times ZA. And then you can type that into the calculator, and it'll give you the approximate A value. Okay, now what you're going to have to do is we have to find out how to do this in the calculator. So let me go up, and I'm going to write this in red so you can see it. So how am I going to do this one in the calculator? Now this one, there's a button. It's on the distribution menu. I and it's called inverse normal. Now, in the olden days, inverse normal sorry, I had to take a little break. The puppies were arguing and growling at each other. Okay, so I was at inverse normal. So the inverse normal notation, I'll write it over here to the left side. So the inverse normal notation on the calculator is, in the olden days, you would just put this area to the left. So area to the left. And that's all you would give the calculator. But nowadays, if you have one of the new calculator, it asks for multiple things. So one way you can do it is just give it the area to the left and be done. But just like in the normal distribution with the CDF, if you want the z-score, you're going to have to put the mean in, the mu, and the sigma for z. So this is one way to do it. This was the old way, the official way that we used to do it, and this matches the notation. So this directly will give you this. Okay? If you put in the area to the left, you put in the 0 and the 1. Now, in the new calculators, it's going to ask you if you want the left, if you want the right, or if, I believe there's another one that maybe if you want the middle. So there's a few different ones that are listed here. So, or at the center, I think it's called the center. So it's a little bit different. So this notation right here with the inverse normal, this will give you the z-score directly. So this will give you ZA. So if you type that into the calculator, it will give you ZA. And I'll flip over to the calculator in a couple minutes. Okay, now you store that. Then you can type this into your calculator, and then it'll give you the answer. Okay, so let me go over to the calculator and see if we can do that. Let's see. This will be my first time going to another page. So let's see. I think the calculator is going to turn out to be a little bit smaller. So I use my Wabbit Emu. There you go. For my tablet, it actually flips to the other side. Okay, so let's clear it. So I go to distribution. There's inverse normal. The area is the 0.2119. That's why you're drawing the picture. And then the mu and the sigma, if you want the z-score, you leave it at 0 and 1. Now, when I hit paste, it puts it like I used to put it. Now, in the olden days, I wouldn't have to put the 0 and the 1 here, and it would just give me the answer because it knew to find a z-score, I would want 0 and 1. But 0 and 1 is fine, and this 0 and 1 will give you the z-score. Now, what's kind of cool, I use second entry to give me the same line again, is if instead you put the 500, 100, it actually gets you the answer exactly. So this finds you the area to the left, and it gives you the answer directly. So it gives you the 420, which is the answer that we started with in the original problem, and we were trying to get. So we were trying to go backwards. So it is possible, and if you go to inverse normal, let me go back to inverse normal. If you go to inverse normal, on some of your calculators, they're even newer than this one, and it says like right, left, center, and then you can choose. The only problem is you don't have notation, and then also what are you going to do when the problems get more complicated? So I don't suggest it. I suggest doing it this way with the 0 and the 1, so you're used to the z-scores, and then that familiarity will really help you. Okay, so these are the two different ways that you can do it. I do it as a check for the 420. But right now I'm going to take that top number. So let me do my inverse normal again. But let me use my 0 and my 1. Okay, the one that will get me the numbers on my Z number line. And then once I found that, I was going to take that and multiply it by 100 and then add 500. I think that's what we were doing. Let's check. Yep, so there's our 420. So we can do that. How we'd write that, let's see if I can memorize this. Negative 0.7998, ... So let me go back to my other screen. Negative 7.998, ... Let's see. So let's see. Okay. So this one would be negative 0.7998, ... Oh, hopefully that's right. I don't remember. Okay, and then this one we got 420 point something something. Now, the only problem with this number up here that I've highlighted in red, in yellow, is that that you shouldn't use rounded answers for future parts of problems. In stats, sometimes they do that, so it's a little bit different. But in math, we're not used to that. But sometimes in stats, they do. I'm going to go back just to check that number. So let's see if I memorized it right. So let's see if I can go back. Cool. So negative 0.7998. That is what I put. Negative 0.7998. Okay, cool. And then this is the answer, and we're doing SAT score, so it makes sense to just round to 3 decimal places. So here you can write inverse normal. You can put the 0.2119, and you can put the 500 and the 100, and it will get you directly to X. Okay, so it'll give you directly to A. So that is possible. Okay, but you won't develop your skills with this conversion formula, and that means you won't be very flexible. So you'll only be able to solve the problem that the calculator knows how to solve, and it'll be difficult if you want to solve for something else. So my suggestion would be to use this notation right here, which is a notation I learned a few years ago. That's kind of cool. Okay, so let me go to the next example. So for the next example, what are we going to do if it gives us the area to the right instead? Okay, so if it gives us the area to the right, what's our plan? And so let's see. Let's say I wanted, so this is example 2. Let's say I wanted the top 20% of SAT scores for math. So I draw the picture, and we already said mu is 500 and sigma is 100 for this situation. So here we go. Here's, this is X, this is Z. I usually make 2 number lines. So this is 0, this is 500. And then right down the middle, and then right here is 100. That's the sigma. Okay, so it's telling me the top 20%. So the top 20% would be that this area right here is 20%. So how I would write that is I would say the probability that my X, we'll call that A, that X is greater than A. You can put an equal to. You don't have to put an equal to. With normal curves, it's a continuous distribution, so it doesn't matter if there's an equals there or not, which is very strange to us. Anyway, so this is supposed to be 20%. But I can't do a greater than sign with my notation. So what I change it to is I change it to a less than sign. And you have to figure out what percent would be less than that same value. A or ZA if you're talking about Z's. So what would the area less than it be? Well, the total area of the whole blue part, think about that, what that's supposed to be. So what percent was supposed to be the whole area? So the whole area was supposed to be 100% or 1. That doesn't have to do with the 100 of the sigma. Okay, so this would be 0.80, would be the rest of it. Now, to use official notation, this would be Z less than ZA is 0.80. And then ZA is equal to the inverse normal. And you have to give it the area to the left. So this is the left area in order to use the notation. Now, to use the calculator, it's a different story. I would say this step right here is optional. This wiggly step is optional if you have the ZA listed real clearly underneath A on your normal distribution curve. Okay, now I'm going to use my conversion formula. So Z equals X minus mu over sigma. So Z is ZA. Got my puppies trying to protect the house, so they're out barking at the window. Okay, so X is A, mu, think of what mu is. So mu is 500, and sigma was 100. And then you cross multiply, ZA times 100 equals A minus 500. Think of how you want to solve for A. So A, add the 500, and you get 500 plus 100 ZA. Then I usually go and type this into my calculator. I think of calculator notation is invisible, but the math analysis teachers probably would like to see it. But for the AP test, the IB test, probably your college professor, they might not have the same calculator, so maybe this isn't the notation. So definitely the inverse notation would make sense, but the inverse normal, typing in what you would type in the calculator, maybe doesn't make a lot of sense. Okay, but it's definitely okay if you also include this on ours. So inverse normal 0.80 would work, but since on the new calculators they have that screen where they ask for mu and sigma, you want to ask yourself, am I trying to find ZA or A directly? So if I want to find ZA, I type that in. Once I type this in and I found out my number, I can then calculate this and find A. Probably I would round it. Or if you do inverse normal, this will find A directly, 0.80, comma, and then you can use the mu from the original problem and the sigma from the original problem, and it will give you directly the same answer as this one. But you won't learn it as well. So that's where you have to kind of make your choice. So I guess I should go back to the calculator. I definitely need to, my new tablet comes on Thursday and I'll do split screens and then we could have the calculator on the same screen as this. But at the moment we can't see that. So let me just click over to my calculator and see what numbers I need. See if I can memorize these. Okay. So here we go. We're going to do this one. Hey, where'd you go? Okay, so for this one, I'm going to do inverse normal. So try to think, where was it? It's in the same spot as normal distribution, which is on the distribution button. Inverse normal, you're going backwards, like sine inverse. I want to give it the area to the left, which is 0.80. The new calculators, you could give it 0.2. You don't have a notation for that, but it would get you the answer directly if you were taking a multiple choice test. And then there's an option that says to the right, but we don't have that. Okay, so 0, 1, that would give me the 0.8416. So 0.8416 is the z-score. How many standard deviations is A away from the mean? Or I could do, and then what, for me to do that one, I would do what? Times 100 plus 500. Oops. Plus 500. And that would give me the 584. But I could also go back to distribution, go inverse normal, do the 0.8, which is the area to the left, give it the 500, give it the 100, but because I'm using the mu and the sigma of the top number line, it's not going to give me a z-score, which is the bottom number line. It's just going to give me directly the answer of 584. So you get the same answer either way. So it's good to use the check. Okay, the next problem I'm going to show you, it won't work the other way. So the bottom thing of the calculator, this part right here, let me take a screenshot and show you. But this one right here, okay, this one right here only works if you're looking for A. If you're looking for sigma, if you're looking for mu, it's not going to find it. So I would say it's safer to use the one at the top. Okay, so let's see if I can memorize those answers. 0.8416, oh, 8416, that has to be 100. Okay, so 0.8416 and 584. So let's get back to that other screen. Let's see if I could remember it. Okay, so this, let me get back to the right orientation. So this was a 0.8416 ... which then when I typed in was 584. SAT score, probably you'd round it to the 0, so like 580 would make sense. You can't get an SAT score of 584. And then this one, if I typed it in directly, it would directly give me the 584. I did put the approximately signs because it's not the exact answer. Okay, so for example 3, let me show you that you have a little bit more of a problem. Okay, and actually I think I'm going to do example 3 and 4 on another video. because I'm not sure how long this video could be. So far I'm at 25 minutes, so I don't know if I'm allowed to do a longer video. I don't know at what point it just quits up on me. So I'll have to test that later, but let me upload this one in the meantime.